All right, Jakob, thank you. Diego, thank you. And thank you, everybody here at Palaeontological and in Bristol for inviting me to do this in one of my academic homes. So I did my master's here with Mike Benton over a decade ago now. And Bristol is also just a very special city for me because my wife is from Bristol and I was married here. So it's really neat to be able to do this. And now I liked Bristol so much and I liked the UK so much that I eventually came back to the University of Edinburgh. And I've been there about 6 years. And actually, I've liked it so much that if all goes according to plan, next month I should become a British citizen. So for at least a few months, I'll have a nice new red passport before I have to trade it in for one of those blue ones we've been promised. But anyway. So I'm at the University of Edinburgh. I've been there about 6 years. I think we've been building up a really nice paleontology group there. And so in this talk, I'm going to highlight some of the work and some of the discoveries that some of our really fantastic students have been doing. But I suppose the real purpose of the talk is to sell books. So I have this newish book out, The Rise and Fall of the Dinosaurs. We're selling them in the back. Some of the proceeds I'll be donating to Palaeontological, and so we'll be back there signing them later. I'm contractually obliged to say it makes a great Christmas present, even as Christmas colors on the cover. So the other thing is when we're in the back after Shu's talk, I know we won't have a lot of time for questions here. So anybody that has questions about dinosaurs, and I'm really thinking more of the younger crowd here, please come in the back and I'm happy to answer any questions. Okay, so enough small talk, because what I want to do here is, in this lecture, tell the story of the dinosaurs. And this is over 150 million years of evolution. I'm going to try to do it, in 20 or 25 minutes. So we should just jump right into it. And so if we go back to the start, if we go back to about 252 million years ago, this is at the end of the Permian period. This is the time of the supercontinent, Pangaea, which stretched from north to south pole, one giant ocean surrounding it, a very harsh desert land over much of that continent. But it was teeming with life, and there were a whole bunch of amphibians and reptiles, and a lot of synapsids, a lot of early relatives of mammals living on that supercontinent. But then something happened, something really terrible happened. And in Siberia, these enormous volcanoes started to erupt. And these were not normal volcanoes. These were basically super volcanoes, just fissures in the earth that opened up and spewed out lava for millions and millions of years. And anything living near Siberia was in trouble. It would have been buried by lava, but this was a global problem because of all those toxic, nasty gases that came up with the lava. So all the carbon dioxide and sulfur dioxide and methane, a lot of these things, as we know, are greenhouse gases. And so this was a time of extreme runaway global warming, and that caused a mass extinction. And not just any old mass extinction, but the worst mass extinction that has ever happened, where maybe up to 95% of species went extinct. And if you want to know more about that extinction, you should read Mike Benton's book, When Life Nearly Died. And I should also mention Mike will have a new dinosaur book coming out next year, which is really good. So keep that in mind. Anyway, there was this great extinction. A lot of stuff died, but some things made it through. And those survivors then, in the Triassic period, the next period of time, had this whole new world to themselves. And so this was a time of great evolutionary experimentation. And so when I was a student here at Bristol and also a PhD student, I became very interested in this extinction, trying to understand what lived and what died, but even more so, what happened afterwards. And so I did a lot of work with Richard Butler at that time, and we worked really closely with this really amazing young student in Poland, Gregor Snedzwicki. And there's a lot, Poland might not be a place you think of when you think of dinosaurs and fossils, but there are a lot of quarries in Poland where they mine clay to make bricks, and a lot of these quarries have layer after layer of rock that are full of fossils, and they span the Permian into the Triassic and throughout the Triassic, and you can read those layers kind of like you can read the pages in a book. And those fossils tell the story of how life recovered after the extinction. But the fossils that are found in those rocks are not normally bones and teeth and all these amazing things that we've seen in a lot of talks earlier today. the fossils we find in those rocks are mostly these kind of things. They're the traces that animals left behind. So handprints and footprints and tail drags and those sorts of trace fossils. Now, about 1 million years after those end Permian volcanoes were erupting, we start to see these tracks in Poland. This is a handprint on top of a footprint. And these things are really small. They're just about the size of cat's paws. And they match quite well with skeletons of animals that are known from other parts of the world. Skeletons that look something like this. So this track maker was about the size of a house cat, I suppose. Kind of looks maybe more like an Italian greyhound, you know, one of those funny-looking little dogs with those long legs. So it had these long, gangly legs, but its legs were underneath its body. It could run fast. And this thing was a reptile. And it's a type of reptile that we call a dinosauromorph, and that's just a technical term for one of those very close relatives of dinosaurs. So this thing is not a dinosaur, but it's something that is kind of on the cusp of becoming a dinosaur. It's those few branches right outside dinosaurs on the family tree. So although this thing is not the direct ancestor of dinosaurs, it's this type of animal that dinosaurs evolved from. And obviously, you can see this thing doesn't look anything like a T-Rex, or it doesn't look anything like a Brontosaurus. This is a small, humble animal that is living in the shadows. And dinosaurs would continue to diversify throughout the Triassic for the next several tens of millions of years. But during this time, although dinosaurs were diversifying, they were not dominant animals yet. They were not at the top of the food chain yet. That would come later. And it was other animals that filled those roles. And we see some of those animals in another place where Richard and I did quite a lot of work with a nice team with Octavia Mateus and Jessica Whiteside and others. We went there hoping we would find fossils of early dinosaurs, but we didn't find any, probably because they're still so rare at this time. You know, you just need to be really lucky to find them. But we did find a graveyard, a bone bed of hundreds of skeletons of these giant temnospondyl amphibians, these things that are about the size of a smart car. So it's these kind of animals that were really the dominant ones in the rivers and the lakes during the Triassic period, when those first dinosaurs were rising up. And these, you know, were brutish creatures. These things had thousands of teeth in their, you know, toilet seat heads there. Dinosaurs or little dinosauromorphs, you would not want to go anywhere near water with hundreds or thousands of these things waiting there in their flocks. But it was no safer on land because in the Triassic, on land, this was really the age of the crocodile line archosaurs. So the first crocodiles and a whole diversity of other animals that are their close relatives. Now today, we all know crocodiles and alligators and gharials. There's not that many of them, though. There's only about 25 species. They all kind of look the same. They all kind of do the same thing. But in the Triassic, you have these crocodile-line archosaurs. Some of them were huge, were the size of SUVs, maybe even getting close to bus size. You have other ones that had horns and spikes and armor. You had some that ate plants. You had some that had sails on their back. You had some that even had beaks, some that even walked on 2 legs. So the Triassic on land was very much an age of this crocodile line dominance. But then something changed because we don't have all these crocs living on and going on and evolving into things like T-Rex. We have the dinosaurs evolving into those animals. And so what happened was, about 200 million years ago, the supercontinent started to break up. Pangaea started to split, and it started to unzip along what is now the Atlantic Ocean. So it started to break apart there. That's filled with water today. But before the water came in, you had volcanoes erupting through those fractures. So this was another time of supervolcanoes, not quite as extensive as the ones at the end of the Permian, but still pretty bad. And this led to another runaway global warming event. It led to another mass extinction, not as bad as the one at the end of the Permian. Maybe 70-ish% or so of things went extinct. But what's important is that extinction decimated those giant amphibians. It decimated the crocs and their close relatives, but the dinosaurs sailed right on through that extinction. It seems like they were barely affected by that extinction. And there's still a lot of mysteries about that, but the biggest mystery is why that is, and I just don't know the answer to that. And that's something that I always tell, you know, younger kids and students, that I think that's one of the biggest questions one of the biggest riddles that's still out there about dinosaurs. What was it that allowed them to do so well when so many of their early competitors died out? So I don't know. It would make the story better if I could tell you why, but somebody here in this room will have to solve it someday. But regardless of the why, it's really only after that extinction that now dinosaurs become the dinosaurs that we all know and that we all love, the iconic dinosaurs. This is when the age of dinosaur dominance really begins. So we're now in the Jurassic period. There's a reason they called it Jurassic Park and not Triassic Park, because it's now in the Jurassic where you have dinosaurs in this new wide open world, free of most of their early competitors. And this is when dinosaurs diversify. All kinds of new species evolve. All the major groups of dinosaurs proliferate. This is when you start to get really big, bus-sized meat-eating dinosaurs. This is when you get giant long-necked dinosaurs. So this is the time that we start to see this sort of world come into being. And we're learning so much more about the early diversification of dinosaurs because people are finding so many new dinosaurs. It really is a golden age now, and it's been that way for a while. People are finding new species of dinosaurs all over the world. Once a week on average, somebody finds a new species of dinosaur. I don't know, probably this room combined, there have probably been 100 or more new species of dinosaurs that people in here have found. And it is amazing, and that's really because paleontology has become a global science. And it's people, young people all over the world, a great diversity of people doing this work, finding dinosaurs everywhere, including, believe it or not, in Scotland, where we are based. And this is another place you probably would never think of when you think of dinosaurs. But there's one place on Scotland where you can find dinosaurs, and these are important dinosaurs because they are Middle Jurassic dinosaurs, and so they help tell that story of how dinosaurs are evolving after that extinction and getting bigger and spreading around the world. And this is the Isle of Skye, which I think is one of the most beautiful, enchanting places in the whole world. Now, I say it's the only place in Scotland to find dinosaurs. That's not really true because Neil Clark has found some dinosaurs on the mainland, and I won't give it away because Neil will have to do that. And we've started to explore some of the other islands. So I'll just say my PhD student Elsa found something really neat a few years ago. I won't tell you what. You'll have to wait for Elsa's paper on that. And by the way, Elsa will be presenting some of her thesis work on Sunday, so make sure to check that out. But we're starting to find new dinosaurs in other places, but mostly right now it's still the Isle of Skye. But it's quite a record on the Isle of Skye. And it is a great place to work because I can take my students there. And I'm totally honest when I say that it's always the students that find the best fossils. It's always the students. And so Amelia's back there somewhere. Where's Amelia? There's Amelia. So Amelia Penny, she's a postdoc now. Amelia did her PhD in Edinburgh with Rachel Wood. And those of you that know Rachel Wood, Rachel doesn't study dinosaurs. She studies the origin of animals and the origin of skeletons. So Amelia did her PhD on these tiny little, first animals, Cloudina and these things that were making skeletons. Yet when Amelia came out with us, she found what I think is by far the best thing that anybody's ever found on Skye, this new skeleton of a pterosaur. Incredible fossil. And there, Amelia is peering at it in the rock. Now, I have to say, as a bit of an advertisement, we've got the fossil prepared, so we are advertising a PhD on that. So if any of you are looking for a PhD, think about doing this one and talk to me about it if you're interested. Now, when we go out to Skye, it's a bit of a challenging place to work. It rains a lot, it's windy, it's cold. The rocks are really hard. We have to cut the fossils out. Usually the smaller fossils with smaller tools. The bigger fossils require much bigger tools. Diamond-tip saws. This is Doogie Ross, who Pallas awarded the Mary Anning Prize a few years ago. This really incredible amateur on Skye, grew up on Skye, native Gaelic speaker, built his own museum, and he's found a lot of the best fossils. He's also, thankfully, a builder. So he has his own saws, and he's great at getting the bones out. Now, there's a lot I could say about Skye, but I just want to tell one story about something neat that we found a few years ago. And so we're in this part of the island. This is the far northeastern tip of the island. It's a place called Duntulm. And I'm taking this picture on one of the rare sunny days. Actually, it rained later that day. It's just a sunny hour. And this picture, we're standing in the ruins, the shadow of the ruins of this 14th century castle, very Scottish scene. And we're looking across the beach. This is at high tide, but at low tide, that beach turns into a rock platform. And we went there because John Hudson, the geologist, showed us a little bone he found there many decades ago, which turned out to be the jawbone of a little crocodile. Not a big croc, because all those big crocs went extinct, really, at the end of the Triassic, but a little croc. And so we went there hoping we would find more, and we were there all day, hands and knees, looking at the rock, and we didn't find anything other than fish bones and teeth, which made Tom Challens very happy. I don't know if Tom's in the room or not, but Tom studies fishes, so he was happy, but those of us who were wanting to find dinosaurs or crocs were not. But then as we, were walking back, we were tired, we were ready to go back home, Tom and I started to notice that there were these big holes on that rock platform, and we just thought they were tidal pools at first. And they are tidal pools. They're full of seaweed and barnacles and the normal stuff you'd expect on the beach. But then we started to notice that there were actually a lot of these things. There were over 100 of these things. And they had a bit of a sequence. There was a bit of a left-right sequence going on. And when we looked at these things from the side, we could see they were actually impressed into the rock. So these things couldn't just be random tidal erosion. They had to be something that formed before that was rock, back when it was just sediment. And then some of these holes were filled in with harder rock, and we could see these little bits sticking off of one side. There's 1, there's 2, 3, 4. And sometimes these things were paired, and there was a big horseshoe-shaped one with the smaller crescent-shaped one. And these things were big. These things were big. They're about 70 centimeters across, so that's about the size of a car tire. And so it dawned on us as we put this all together that we actually had found fossils, dinosaur fossils, just not bones and teeth. These were trace fossils. They were footprints and handprints, but big ones, much bigger than those ones from Poland, because we're in the Jurassic now. Dinosaurs are diversifying. They're getting bigger. And there's really only one type of dinosaur, or one type of animal, that's ever lived on land in the whole history of the Earth that was so big that it would leave an impression the size of a car tire every time its hand or foot hit the ground. And of course, we're talking about the giant, long-necked, pot-bellied sauropod dinosaurs, so the Brontosaurus, Diplodocus types of dinosaurs. The ones that were making their footprints on Skye were probably about 10 or 15 meters long. They probably weighed in that 10, 12, 15-ton range. Hard to estimate for sure. But later on in the Cretaceous period, well, Diego can tell you all about how big sauropods got in the Cretaceous. Things like Patagotitan got to be the size of Boeing 737 airplanes. And I don't know how you excavate those things. But these are just monstrous, incredible biblical animals and a real feat of evolution. But we start to see them here in Scotland getting big. Now, we've actually found a lot of other track sites, and a lot of the students have found a lot of the tracks. So Davide, who's here, he's found some very interesting new tracks. And Davide will also be presenting his PhD. He's already finished his PhD, but he'll be presenting a lot of the results of it tomorrow on marine reptiles. Now, my student Paige, who's not here, Paige did her master's on these tracks. And Paige has a geology background, but also an engineering background. So Paige is really good with machines and with fixing things and building things and experimenting with things. So Paige did her master's using drones to map these track sites. And so she's made these beautiful 3D models of the track sites. And these things tell us how many tracks we have and which ones form track ways and how fast the dinosaurs were moving. And they tell us more about the environment. And so with these maps and with information from the rocks, we can tell that these dinosaurs were kind of just loitering around 170 million years ago. These footprint sites are snapshots into the days in the lives of these dinosaurs. And they were making those tracks in shallow lagoons. They were walking in shallow water. Maybe that's not an environment we think of when we think of dinosaurs, but I think it's just another sign that by the Jurassic period, these dinosaurs are diversifying so much and spreading around so much that they're now living in all kinds of different environments, not just the dry land, but lagoons and beaches and so on. But it's not only the giant sauropods. We also have footprints, only footprints, of these things that walked on their hind legs that are much smaller, three-toed footprints. And these are footprints that are left behind by theropod dinosaurs, by the meat-eating dinosaurs. And they were left behind by early cousins of things like T-Rex, maybe even early Tyrannosaurs themselves. It's hard to tell for sure because we only have a few bones of these animals, including some teeth. Now, Chloe here, who's doing her master's in Bristol now, when Chloe was an undergrad in Edinburgh, she described some of these teeth. We can't quite say if they're Tyrannosaur or something else, but we do know that in other parts of the world around this time, the first Tyrannosaurs were evolving. This is because of the work of Xu Xing and others. So, in the Jurassic, Tyrannosaurs got their start. They didn't start out like T-Rex. They started out as human-sized hunters, as lightweight, slender, fast-running animals, things like guanlong. And then somehow, during their evolution, over time, they transitioned into these giant, brutish apex predators that everybody knows when you look at T-Rex. Now, for most of their history, they were small. This is the norm for a Tyrannosaur. It was only at the end of the age of dinosaurs that they became really big. So there's a question of why that happened. And it's probably a very complicated answer, but we think we might know part of that answer. And some of this new evidence comes from a new dinosaur that was discovered a few years ago in Uzbekistan by some colleagues of mine. And we worked on this thing together. This is a Tyrannosaur. It comes from the Cretaceous, so it comes from after Guanlong and those first human-sized Tyrannosaurs. This one's a little bit bigger. It's about the size of a horse, but still nowhere near the size of a T-Rex. But what's important about Timurlengia is we have quite a lot of bones. We have a pretty nice skull, at least the back end of the skull, and there it is looking from behind. There's the foramen magnum leading into the brain cavity. There's the occipital condyle. There's some of the sinuses that are broken. And like so many paleontologists now, we can just put this thing in a CT scanner. This is a CT scanner in Edinburgh that Ian Butler is a geochemist colleague of ours. He built this himself, so it's a great scanner. And he scanned this fossil. And so remember, that's the skull, the brain cavity's inside, so we can use the x-rays from the CT scan to build a digital model of the brain and the sinuses and the nerves and the ear and so on. And we can see what the brain of this Tyrannosaur looked like. And so it looks something like this. This is just the back end of it. The front end is too damaged. It's not very pretty, so I didn't include it. But the blue bit is the brain. This pretzel-shaped thing is the inner ear. And we can tell some important things there. We can tell, first of all, that this brain is pretty big for a horse-sized dinosaur. So this dinosaur was fairly intelligent. Hard to make an exact parallel with things that are alive today, but it was more intelligent, I think, than most people envision dinosaurs. But even more than that, it has this really long cochlea in the ear. That's this triangular thing that's sticking down. And we know from modern animals that the length of the cochlea correlates with hearing range. So we can tell this Tyrannosaur could hear really well. So it looks like that these early Tyrannosaurs, these human to horse-sized Tyrannosaurs, were evolving bigger brains and keener senses as they were living in the shadows as second or third tier predators in a world where there were still big allosaurs and carcharodontosaurs and spinosaurs and those kind of things. And then, when some of those other big predators died out, Tyrannosaurs seemed to have seized that niche. And they became so successful in that niche because they combined brains and brawn. And T-Rex was the ultimate one. It goes really without saying, but T-Rex, the size of a double-decker bus, 7 or 8 tons, head the size of a bathtub, 50-some banana-sized teeth, crushed through the bones of its prey, as we saw from Carl's talk. No, it couldn't. And yes, it had those pathetic little arms, but you put all that together, this is really the ultimate dinosaur predator, and one of, the biggest predator, pure predator that's ever lived on land. And it was brains and brawn. Now, there's another type of theropod dinosaur, a much smaller type, that went a different way in evolution. They got smaller and smaller over time, and they elaborated their feathers. And these were the Dromaeosaurs, or the raptor dinosaurs, and the Troodonids, these small dinosaurs that evolved into birds. And normally, at this point in the talk, I would go off on some big loquacious thing about the bird evolution and feather evolution. However, we've seen some pictures of some of these things already today, and you're going to see more because we have in the room 3 of the world's experts on this. So Many of you have already heard Darla and Jingmei speak. We're all going to be indulged when Shu speaks in a few minutes, and you'll get the full story of bird evolution there. But suffice to say, a lot of dinosaurs very bird-like, and I think most dinosaurs probably had some type of feather. Okay, so we're getting closer to the end of the story. T-Rex lived at the very end of the time of dinosaurs in the Cretaceous. T-Rex lived in a world that looked like this. A world that was becoming more like our world today. Not exactly the same, but you can start to see the continents have been moving around, and as the continents moved around, the dinosaurs were along for the ride. So by the Cretaceous, you had different groups of dinosaurs living in different places. And then it all came crashing down 66 million years ago when that 6-mile-wide asteroid fell out of the sky, smashed into the Earth, the force of over 1 billion nuclear bombs. It punched a hole in the crust that was over 100 miles wide. You can see that crater, parts of it down in Mexico today. And this really does look like it wiped out dinosaurs very, very quickly. It unleashed a cascade of environmental destruction, of wildfires and tsunamis and earthquakes and volcanic eruptions and dust blocking out the sun, all kinds of chaos, and the climate and the environment changed so quickly that dinosaurs really couldn't adapt to it. Now, there's always debate about how dinosaurs were evolving in the lead up to that asteroid impact. Were they declining, or did the asteroid take them out at the top of their game? I'm very much in the latter camp. With work we've done with Graham and others, Graham Lloyd, we've looked at dinosaur diversity over time, and we see dinosaur diversity was quite strong right up until the very end. T-Rex was there when the asteroid hit. Triceratops was there when the asteroid hit. In South America, you had giant sauropod dinosaurs there when the asteroid hit. In Europe, it was just a bunch of islands at that time. You had dwarf dinosaurs living on these islands when the asteroid hit. So there were still lots of dinosaurs around, a great variety of them. And then they all disappear from the fossil record so abruptly 66 million years ago, except for a handful of those small, beaked, probably seed-eating birds. And then the world changed again. There was a largely empty world again for new animals to conquer. And this is where a lot of my research and the research of my students, especially a lot of my newer students, is turning to these days. We want to understand what happened after the dinosaurs died. So we're doing a lot of work in New Mexico, one of the best places in the world to find some of the last surviving dinosaurs and also the animals that took over from them. This is more traditional paleontology. This isn't Polish quarries or Scottish misty islands. This is badlands and deserts and what you see on TV when you see people digging up fossils. Now, I work there with my very good friend, Tom Williamson, and I've also been very privileged to be able to train some of my students in New Mexico. And about a year ago, my first PhD student, Sarah, who also did her master's here, as you're starting to see, pretty much everybody's done their master's in Bristol. Sarah finished her PhD about a year ago, and I think already she's become one of the handful of leading experts on those animals that immediately took off and took over after the dinosaurs died. And the animals I'm talking about are these things. Now, you might be able to tell what those are, because you all got similar things inside your own bodies. These are teeth, but these are not the steak knife teeth of T-Rex. These are the cusped teeth of mammals. And so it's mammals that took over after the dinosaurs died. The first mammals evolved with the first dinosaurs on Pangaea, and they diversified. And they evolved into all kinds of different creatures, all kinds of different diets and behaviors, but they remained small as they lived with the dinosaurs. But within a few 100,000 years at most after the asteroid impact, we now have mammals in New Mexico that are almost the size of cows. We have digging mammals, burrowing mammals, we have fast-running mammals, we have saber-toothed flesh-eating mammals, and we have another type of mammal that's small, that has long, gangly limbs, that looks a little bit and is about the size of an Italian greyhound. But this type of mammal has opposable thumbs, and it could leap from the branches. And so what you're looking at here is one of the very first primates, one of our ancestors. So, all this stuff is connected. And I think this goes to show that if that asteroid didn't hit, if that was a near miss, that the dinosaurs may have just kept on persisting, kept on evolving. Who knows what they would have evolved into? And we probably wouldn't be here. And I think there's another lesson there as well. And this is a thing I think we want to think about. I mean, I think this is a fun story. It's great to tell these stories of empires rising and falling. But I think there's relevance here because the dinosaurs were an empire. They were around for over 150 million years. They evolved into some of the most incredible animals that ever lived. And then, suddenly, when that asteroid hit and the climate and the environment changed so quickly, they could not cope. And they died out. Now, we've only been around as a species for about 200,000 years. Our world, especially the temperatures, seem to be changing a lot faster than they ever did during the time of dinosaurs. So how will we respond to that, and can we do anything about that? So, on that cheerful note, I'll just thank you all for your attention, and again, thank all of the wonderful students and collaborators who have all worked together, so many of you, to tell this story of dinosaurs. So thank you very much.